Hi, so the video, sorry, not the video, the derivative that we're going to focus on in this video is the derivative of sine squared of x. Of course, when we say sine squared of x, what we just mean is sine of x all squared. So sine of x all squared. And so, yes, we want to differentiate this function. And to do this, as you can probably imagine, we're going to need to use the chain rule, which we did in previous videos. So because we've got a function, namely the squared function, and within that squared function, we've got this sine function, we're going to need the chain rule to do this calculation. So yeah, so what we're going to do then is differentiate with respect to x this sine of x all squared. And the key with the chain rule is that we differentiate the function within the squared function first, which is this sine function. And when you differentiate that sine function with respect to the variable, you get cos of x, because when you differentiate sine, you get cos. So what we're going to get then, so yeah, d by dx of sine of x, which will get us the cos of x. And we multiply this by the derivative of this sine of x squared, the derivative of this sine x all squared, I should say, with respect to the sine x. So again, this is just applying our chain rule formula. So yeah, as I said before, when you differentiate sine with respect to x, you get cos of x. And when you differentiate sine squared with respect to sine, I mean, that's just like differentiating x squared with respect to x. You would get 2x. So here what we're going to get is 2 sine. So 2 sine of x. And then rewriting this in a neater way, you're going to get 2 cos of x times by sine of x. Okay, yeah, so that's basically our final answer then. So when you differentiate sine squared of x, you get 2 cos of x times sine of x. What you may notice is that there's an identity that you may have seen where you have 2 cos of x times sine of x, and that would be this identity, so sine of 2x, so one of those double angle identities. So sine of 2x is equal to 2 cos x sine x, and you can also write that as the answer here. So yeah, so the derivative of sine squared is sine of 2x, which is the same as 2 times cos x times sine x. So yeah, that's our result for this derivative. So you can actually generalize these sine to the power of something derivatives, and that's what I'm going to do now then. So let's say you've got a derivative that we want to calculate, and let's say that function that we want to find the derivative of is sine of x to the power of, let's just say n, where n is some real number. Then again, a similar process. So we've got this power of n function, and within that power of n function, we've got the sine function. So again, we could just do the chain rule. So differentiate the sine function within the power of n function with respect to the x variable, multiply that by the sine of x to the power of n with respect to sine of x. So we know how to differentiate x to the power of n. That's n times x to the power of n minus 1. So same kind of thing here. You're going to get, so with this d by dx of sine of x, we know that's cos of x. And then with this second bit here, differentiating, as I said, x to the n is n times x to the n minus 1. So therefore, this is going to be n times sine of x to the power of n minus 1. And so as a final conclusion then, what we're going to get is d by dx of sine to the power of x, sine of x to the power of n, I should say. We're going to get n times cos of x times sine to the power of n minus 1 of x. And that's our final result. of course, where n does not equal 0, but for any other real number, this would work perfectly. And even if n was 0, it would still work because you would get a 0 there. So yeah, you can actually ignore that because it would work for any real n value. Perfect. Yep. So that's the end of this video.